All right, so today I want to review first our fraction benchmarks. So let's do this in your notebook with me. We're going to just draw a really quick basic number line. And we have 0, 1/2, and 1. So these are just like our benchmark fractions. So our benchmark is a really good way to just compare fractions to really, I like to think of them as friendly fractions. I don't know if you guys remember when you were in like first grade, second grade, and they call them friendly numbers, which were usually multiples of 10 or like a close rounding number. I think of these as friendly fractions. These are ones in your head that if I said, hey, where is 1/2 on a number line? Where is 0 on a number line? Where is 1 on a number line? You guys would know it right away. So these are just our benchmark fractions, and these are really good to compare numbers, which we've talked about before, like is it closer to 1? Is it closer to 1/2? When we were talking about comparing fractions, I don't know if you guys remember, we were saying like a good example here was 7/8, and I'm just gonna use greater than, less than. Let's say 2/3. And you guys were saying, oh, well, 7/8 is one small piece away from 1, while 2/3 is a big piece away from 1. So we were doing this then, where you were using benchmark fractions then, and we're gonna bring them back today to do some rounding with fractions. So just make sure when you have this, so have this in your notebook, and when you're thinking of benchmark fractions, you're thinking of comparing them to 0, 1/2, and 1, which should be pretty easy to do, and hopefully we can do that in our head these days. So the first one I want to give you is 5/8. Is 5/8 closer to 1 or closer to 1/2? And I want someone to give me an answer, but I don't want you to do it just yet. I want everyone to have some time to think. If someone was to ask you, hey, is 5/8 closer to 1/2 or 1? I want you to think about what you would say, but don't unmute yourself just yet because I want to give everyone a chance to think.
Wearing that today a little bit, you know, but nothing too crazy.
All right, so let's make sure we're on mute here. There we go. If someone was to ask you,
No, next month.
I want you to think about what you'd say. Does anyone have an answer? So if I said, hey, is 5/8 closer to 1/2 or 1, what would you say?
I already had it.
Radian, what would you say?
It's 1/2.
And why though?
Well, if you take decimals, which is kind of what I did, 0.625 being 5/8. And that might be confusing, but just go with me on it.
Okay.
It's closer to 0.5 being 1/2 and not 1.0, because you can simply round it.
Okay, so I like your answer, but we're not doing decimals right now, we're doing fractions. So how would you explain that to someone in a fraction example?
Well, you would take 5/8 and try and simplify it into anything you can. So you could take it as 1/2 plus 1/4. And then you have the simple just 1/2. But there's a half in there. It's not closer to 1.
Okay, so let's think about, I want all you to think about really quick. When we think about eighths, if we're working in eighths, what would be 1/2?
I mean 1/2 and 1/8.
Okay, so Radian, when we're working in eighths, what would 1/2 of it be?
1/2 of 1/8.
No, 1/2 of a whole when we're working in eighths. So we know if we're working in eighths, this would be 0/8, right? This would be 8/8. And what would our 1/2 be?
4/8.
4/8, there we go. So if you guys look at this, we know that 5/8 right here would be closer to 1/2, which would be 4/8 than 8/8. You guys can kind of think about where it would fall and use your best judgment. Most of you in your head, if I said, where's 5/8, you'd be like, somewhere about here, right? 5/8 is closer to 1/2 because when we're working in eighths, 1/2 would be 4/8. It's closer to 4/8 than it is to 8/8. I want to give you one more really quick. Let's think about, I'm going to give you a little bit trickier one here.
Why am I hearing popcorn pop?
I don't know, honey. Let's leave everyone on mute. Let's think about 2/8. Is it closer to 1/2 or 0? I want you guys, maybe in your notebook, write a couple sentences really quick how you'd explain this to someone. So if I said, is 2/8 closer to 1/2 or 0, what would you say? I want to see what you'd say to someone. And don't unmute yourself. Let's give everyone a quick second, okay? Now, is there someone different?
I got it.
All right. How would you explain it, Bella?
So 2/8 is closer to 1/2 because 2/8 the next number down would be 1/2 for them if it was like this.
So
And
Bella,
then-
let's think about, let's do our first things first. When we're working in eighths, we know this is 0/8, right? Bella, would we decide 1/2 would be an eighth? Do you remember we just did it? What's half of 8?
4.
4, good. And then our whole would be 8/8. We know we're not way over here, right? We're very far away from 8/8. So now let's think, Bella. We have 0/8 and 4/8. What would fall right in the middle there?
4/8.
Well, let's think about here. I'll draw the little line right there. I have 0/8. I have 4/8. I could even do this. I could go like this. 1/8, 2/8, 3/8, right? So when we look at our 2/8 here, and I ask you guys, is 2/8 closer to 0 or 1/2? What do you notice now, Bella, that you can see it?
2/8 would fall in the middle.
It's right in the middle. So I actually tried to trick you guys with a trick question. So Bella, is it closer to 1/2 or 0? What would you say?
1/2.
Well, really, it's right in the middle. You'd say something like,
It would be equal.
it's equal, it's an equal distance. It's 2/8 away from 0, but also 2/8 away from 1/2. So that one's a tricky one because you're like, well, technically it's in the middle of 0 and 1/2. So I want you guys to keep these benchmark fractions in mind. I'm going to keep them going on my board. They might get a little messy, but I'm going to try to leave this up here for you. So if it helps you to draw your benchmark every time, that's fine. Or if you, somewhere in your notebook, just have this visual for yourself, I think it'll help you a lot. So now we're going to do it with adding fractions. So here's what we have. I want you to think about 3/8 plus 5/6. And here's what I want you to do different. I want you to say equals about something. I don't want you to actually solve it. We're working on this word called reasonableness. Has anyone ever heard the word reasonable before? Anybody? Going once.
I have.
Yay, what is it? What have you heard it? What do you know about it?
Reasonable means like something like you understand it, like it's reasonable, like you're okay with it.
You're okay with it, right? So if I'm like, hey, do you guys think $1.5 million is a reasonable price for a car? What would you say?
No, it's not.
No, definitely not reasonable. If I said, do you guys think $15,000 is a reasonable price for a car? What would you say?
I guess so, yeah.
Yeah. So reasonable is it okay? And I'm going to use your question. Is it okay? And does it sound right? We don't actually have to solve for it. And a lot of times, you guys, with reasonableness, it's going to lead us to rounding. So I was talking about this with the fourth graders. I said a good word to use here is about. About. So if someone says, is it reasonable? Is it about that? So I'm going to give you a good example with some basic addition for reasonableness. So think of if I was to ask you, 200 plus 200, is 7,000 a reasonable estimate? I hope. No. Okay. I hope we don't say yes to this one, right? It's not reasonable because you guys know it's 400. It's nowhere near. But what if I gave you a trickier problem? What if I said 989 plus 865? Would a reasonable answer be 2,000? Take a quick second to think. Does anyone have an explanation?
Yeah.
For this? You said yes, and why would you say yes? Ridian, do you want to mute and unmute? I think it got stuck.
It's most likely rounded to 1,000, 2,000 if you round it to 1,000 or 100.
Yeah, exactly. So it's not exact, is it?
Nope.
No, and with reasonable, guys, it doesn't have to be exact. Is it close? Is 989 plus 865, is it about?
Yeah, my answer was yes.
Hold on, I don't need your
4 for it, and that is if you run it to the nearest 1,000, you get 2,000.
Yeah, so it's about 2,000. So when you guys think of this word reasonable, think of the answer, is it about 2,000? Is it about that? So now let's go back to our actual fractions, now that we've kind of got our brains going on this. I have 3/8 plus 5/6. About what would that be? I want you to take a quick second, think about your benchmarks. What is 3/8 pretty close to? What is 5/6 pretty close to? And about what would you get? I don't want you guys finding a common denominator. I don't want you guys actually breaking this down. I want you just getting close. So find a benchmark fraction. What benchmark fraction, I'd love to hear from somebody else, what benchmark fraction is 3/8 close to?
It's close to 1/2.
Thank you, Asher. It's close to 1/2, right? It's not exactly 1/2, but it's close.
And 5/6 is close to 1.
And 5/6 is close to 1.
Yep.
So if someone was to ask you to find a reasonable answer for 3/8 plus 5/6, I could find my friendly benchmark fractions and say 1/2 plus 1 is 1.5. So my estimation would be, okay, 3/8 plus 5/6 is about 1.5. No, it's not exactly 1.5, but a reasonable answer could be 1.5. I just rounded it to the closest benchmark fraction. I want to try one more with you guys, and we're going to start adding in some wholes. Same idea, but we're going to still round it. So let's try this one. We're going to do a mixed numbers this time. 2 and 5/6 plus 7 and 1/8. Again, I want you to give me just a reasonable answer. It's about something. So I want you to take a quick second, round it to the closest reasonable number, and then let's talk about what we got. So give everyone a quick second to work through it before we unmute ourselves, okay? So think about your benchmark fractions. Look at your fractions at the end here. What are they close to?
2 and 5/6 is close to 3.
Thank you, Asher. I love that you're speaking up today. Do you want to solve the whole thing, Asher, or just that one?
Just that one.
Okay. Does anyone want to finish Asher's thinking?
The other one, 7/8 is about 7.
About 7. I like how you use the word about. So Asher's decided that 2 and 5/6 is close to 3.
Yeah, and that's what I got.
Okay. Now Bella B, what would a reasonable answer be now that we've found our friendly numbers?
10.
10. Good. So if you wanted to go through this, you could say 2 and 5/6 plus 7 and 1/8 is about 10. Because 2 and 5/6, I look at my fraction at the end, 5/6 is really close to 1. It would be somewhere about right here. So 2 and a whole would be 3. 1/8 is really small. It's way down here. So that puts us at close to 0. So I'd have 3 plus 7. Now, I want to give you guys a second. We think a reasonable answer is about 10. Now I want you to actually solve it and see if our reasonable answer makes sense. This is when you're going to have to find your common denominator. So now we're at 2 and 5/6 plus 7 and 1/8. What is it actually? So give yourselves a quick minute to work on it. Find your common denominator first. I'm going to have everyone mute up, and then we'll see who can help us solve it, okay?
This is what my answer is.
Hold on, Rydian. I want to give everyone a second to think, okay?
When?
Just a minute. I want to hear from some other people too. Maybe Maddie or Addie, Justin. It'd be lovely to hear from you, Gio, Amelia. Someone we haven't heard from yet. Who can find the common denominator for us? Let's start with that.
The common denominator is 48.
Oh, okay. So you did it in 48. Okay.
Yeah, I multiplied them by each other.
Okay. And what'd you end up getting? So 5/6, you're telling me I have to multiply by what?
By 8.
8, because you're multiplying it by the other denominator. Okay, and what'd you get?
And I got 48.
Do you think you could make it smaller?
I'm not really a simplifying person.
You want to try it? Let's try it together. We always try it with 2, right?
Yeah.
What's 40 divided by 2?
40 divided by 2 is 20. And
Okay.
48 divided by 2 is 24.
Okay, cool. Could we go smaller?
Yes.
Okay, let's do 2 again.
That one would be 10.
Mm-hmm.
And the bottom one would be 12.
Could we go smaller again?
Yeah.
What'd you have now?
So 10 would be 5.
Mm-hmm.
And 12 would be 5/6.
Haha, look how we did that, Addie. So I wanted to show you, it's because Addie, I know you like to say, I'm not a simplifying person. Addie, look what you just did. You started at 40/48, which we will use for this problem, but I just wanted to kind of use you as an example. We simplified it all the way back down to 5/6. Do you see how that works, Addie?
Yeah.
Okay. Thank you. I was just trying to, we're going to leave 40/48, but I just wanted to show you that despite the fact you say you're not a simplifying person, look what you just did. You got it down to its smallest form, and you know it's correct because that's what we started with. Okay? So thank you, Addie, for being brave on that one. I appreciate it. So Addie says she would like to work with 2 and 40/48 plus 7, and then what do we need to multiply these eighths by, guys?
6.
6, good. If we multiplied 6 times 8 here, then we need to do 8 times 6 here because they are a fact family. I end up with 6/48. Now can I add them because they're both 48?
Yes, you can.
All right. What do you want to add first?
You should. I want to add the fractions first.
Yes, ma'am. What if my fractions become an improper fraction? Then what do I have to do?
Then you need to take a whole out of the fraction and put it into the holes.
And that's why it's important we add the fractions first, right? Just in case we go over. But in this case, I see 40/48 plus 6/48. So Addie, how many 48s do I have?
46/48.
Yes, ma'am. And then my whole numbers, I have 2 plus 7.
And 2 plus 7 is 10.
Oh, is 9, right? And if you wanted, you could go a little smaller again, and you could go down to 23/24. But after that, we're done because 23 can't go any smaller. That's a prime number, that's it. So you could say 9 and 23/24. I know that was a lot of steps, you guys, and I was just kind of working through it with Addie as an example. But I want you to look. I now have 9 and 23/24. That's really close to 1, right? Was our reasonable answer of 10 close? What do you guys think? Is 9 and 23/24 really close to 10? Gio, what do you think?
Yeah.
Yeah, and why do you say that? Why do you agree it's close? Think about,
Because
Gio, think about 23/24. Where would it be on my number line?
it would be close to the whole.
Yeah, it'd be like 1/24 away. It would be like, oh my gosh, maybe even closer than that, right?
Yeah.
Awesome. Gio, when I do the next one with subtracting, would you be willing to round it for us?
Sure.
Okay, so we'll do a much easier one now. Let's go to an easier one. I'll take it easy on you, Gio. All right, let's do this. We're gonna have a 2-step. 5 2/3 minus 3 1/6. I want your guys' estimate, your reasonable answer, it's about something. And then I want you to actually solve it. So Gio, I'll give you a quick second. Can I call back on you in a minute for the estimate?
Yeah.
Okay. And then maybe, let's see here, Justin, would you be willing to solve it for us? So we could have Gio give us the estimate, and then Justin, you could give us the exact answer, okay?
I got my answer already.
Okay, 1 second. Gio, did you get an estimate?
Almost done.
Okay, let's give everyone a few more minutes then. You guys, when you're working on your estimate, think about where 2/3 would be on your number line. And think about where 1/6 would be on your number line. And if you want, you guys, if rounding, if it helps for you to actually see it, you could draw this benchmark number line every time if that's something that's really helpful for you. Gio, whenever you are ready, will you tell us what benchmark fraction 5 2/3 is closest to?
It's closer to 1/2.
Well, let's think. So if I was to do thirds, I'd be about here and then here for 2/3. Oops. Oh gosh. 2/3 would actually be closer to 1. This one though, Gio, I feel like you could kind of go either way. It is closer to 1. But I do think, actually, no, you know what? That works. I mean, this one for thirds, guys, I'll give you a little bit of flexibility. Because it's kind of harder. Gio, was it a little bit harder to visualize 2/3? What do you think?
Yeah.
I think you guys, for some of these, as long as you're close, you're right, Gio, it is closer to 1/2. As long as you're close, you guys, on these ones, that's fine. Some of them are really obvious, like Gio, 3 1/6. What is it obviously closest to?
0.
Yeah. So some of these, you guys, if it's close-ish, you're fine, okay? So you're right, Gio. Sorry, I was wrong. You were right. So you're saying 5 1/2. Is that what you're deciding on?
Yep.
Minus 3 and nothing. So just 3, right?
Yeah.
All right. So what was your estimate then, Gio? All right. So let's think about it. If you took a half away from 3, where would you be?
2.
2 1/2, right?
Mhm.
Yeah. Okay, so let's do this. Do you want to change it into halves? Would that help you?
Yeah.
Okay, so how would you do that? Remember, 5 times 2 is 10. Add one more, you're at
11.
11 halves minus
3.
6 halves. Is this better for you?
Yeah.
Okay, and what do you end up with here? What's 11 minus 6?
5.
So 5 halves, or 2 1/2. All right, so we want to say our answer is somewhat close to 2 1/2, right? Justin, will you give us our exact answer?
Our exact answer is 2 1/6.
And how did you get that? What did you do? Because I noticed we have 5 2/3 minus 3 1/6. We cannot subtract those, can we?
Well, we can because 3 is a multiple of 6.
Good work. So what do we need to multiply it by?
We need to multiply 3 by 2 to get 6.
All right, and then whatever I do to the bottom, I got to do to the top, right?
Yep.
So I'm left with what? 5 and 2 times 2 is?
4
Good. Yeah,
and 3 times.
you're good. Yeah. So I have 5 4/6 minus 3 1/6. Does this look a little bit better now? What do you think?
Yes.
Yeah. Okay.
Mhm.
All right. And 5 minus 3 you said was 2. And then 4, 6 minus 1/6 gives us,
3/6.
do you want to make 3/6 any smaller? What do you know 3/6 is equivalent to? Ridian, my equivalence friend. 3/6.
1/2.
Thank you, Ridian. So you could say 2 3/6, or if we're working on our simplifying and pushing up, it'd be 2 1/2. Hey, it's funny. Look at our estimate and look at our exact answer. I love it. Cool. Okay. How are we feeling? I want you guys to remember today as you go through this, you are always gonna have two answers. One is your estimate. It needs to be reasonable, right? So your estimate, and you guys can write this in your notebook if you'd like to remember this. Your estimate is rounded to the nearest benchmark fraction. That's what your estimate is, okay? And if you guys want, you could actually create your number line. Sorry, I'm trying to talk and write at the same time. Let me finish. All right. If you guys want, for each one, if you like, and you don't have to, if it makes it easier for you to see, you could draw your like little benchmark 3 fraction number line for each question, if that's something that helps you see your fractions better, and then put your 2 fractions on the number line if you need that. Or just have this at the top of your page and just look up at it and say, okay, where do I think that would kind of fall in? Okay. So everyone is going to have 2 parts. It's going to have an estimate and then it's going to have an actual. And then this is your exact answer. And this is where you're actually going to have to find, and I'm going to write here for you, common denominator. Remember, when you're doing your estimation, you don't need to find a common denominator. You're just getting close. And then your actual, that's where you actually have to solve it.